Okay, this is just a quick video to teach you about ions. So we're going to be on page 40, and hopefully if you've been following along with us, you already have some notes on page 40. If you don't, you want to go back and watch the valence, electrons, and families notes video. Get these notes, because they will help us out with ions. So, first thing we need to do is remember something we talked about last time called the octet rule. And the octet rule, remember, says the atoms are most stable when they have a full valence shell. Remember, the valence shell, or the valence energy level, is that outside energy level of the atom. And for most atoms, being full means having 8 electrons. So that's why this is called the octet rule. All of the atoms want to end up with 8 electrons. So I drew a picture of a chlorine atom. And if we look at chlorine, we count the number of valence electrons it has. It's got 1, 2, 3, 4, 5, 6, 7. Okay, so it almost has 8, but not quite. But it can actually get 8 valence electrons. All it has to do is get an extra electron from somewhere. In fact, it's going to steal it from another atom, but we'll talk about that later. So if it can go steal an electron from another atom, it can have 8 valence electrons. But something happens to it when it does that. Because electrons have a charge, hopefully you remember that electrons are negative. So before chlorine gained this electron, it was neutral. It had 17 protons. I didn't draw them all here. But in this nucleus there would be 17 protons. And it had 17 electrons. And they canceled each other out and it was neutral. But now that it's gained this extra electron, it now has an extra negative charge. So now chlorine has a negative charge, and we would write it like this, and it has become an ion. So we're going to write down what an ion is. An ion is just an atom that has gained or lost electrons. Okay, so there are a couple of types of ions. One type of ion is called an anion. And an anion is a negative ion. And anions are usually formed by non-metals. So I want to look at the periodic table again and remind you where the non-metals are. So you grab a periodic table here. Okay, so remember this bold staircase line, that basically divides the metals from the non-metals. I know there's some metalloids in here, but we don't need to worry too much about those. Just remember the metals are on the left and the non-metals are on the right, except for hydrogen, which is a non-metal, even though it's over there. So the elements over here are going to gain electrons and become anions. And that makes sense because these elements are close to 8. So they just have to gain an electron or 2 or 3, and then they can be stable. It actually makes them stable to become negatively charged, which is interesting. Now, the other type of ion is called a cation, not cation. Sometimes people see this and they think it's cation, but it's cation. That is a positive ion, and it is formed by metals. So all the stuff on this half of the periodic table is going to form cations. They're going to form positive ions. Now let me show you an example of how that would work, why we would form positive ions. So here is a sodium atom. If we count the valence electrons for sodium, it just has 1 valence electron. So you might be thinking, oh, well, sodium needs to gain 7 electrons to get an octet, to become stable. And theoretically it could, but it's almost impossible to gain that many electrons. It's just not easy. There's a much, much easier route that sodium can go to become stable. And what it would do is it would lose this electron. So this electron goes away, and then here I can draw you a picture of what sodium would look like after that. that whole outside energy level would just be gone because there was only one electron there to begin with, and it lost that electron. So now, underneath this energy shell, sodium has a full valence shell. So it just loses one electron. Now it's got a full stable shell, and it's stable. But since it lost an electron, it lost a negative charge. So that means it's now got one more proton than electrons, so it becomes positive. So you got to remember that when we lose electrons, we become positive. If we gain electrons, we become negative. Very important to remember that. Now, can atoms lose protons to become ions? No, it's always electrons. We either lose or gain electrons. So it turns out that you can predict what type of ion an element can form, or is going to form, by where it is on the periodic table. Let me show you in your textbook. There's a page in chapter 3 that has a nice diagram of this. If I can find it. Here we go. So this is page 92. So everything in this first column, like sodium that we just looked at, is going to form a +1 ion. Everything in the second column is going to form a +2. So they have 2 valence electrons, so they will lose those 2 to become positive. Now, these transition metals, they do lose electrons. They're always positive, but they can lose different numbers. They're not very predictable. So we skip over them, but everything in the boron and aluminum column is going to lose 3 to become +3. This column right here, they are not very stable. Well, they are pretty stable the way they are, and losing and gaining electrons doesn't really help them. So they don't really become ions very often. So we don't have a number for this column. You'll notice these ones do, these 2 elements do become ions, but these 3 don't, and you don't need to worry about these 2. Okay, then we get over here. So the nitrogen column, elements in this column have 5 valence electrons, so they would need to gain 3 to become stable. So elements in this column will form -3 ions, and then this column's -2, -1, and then the noble gases already have a full valence shell, so they do not form ions. All right, so what you need to memorize is this order. So the columns go +1, +2, +3, skip, -3, -2, -1, skip. So 1, 2, 3, skip, 3, 2, 1. And you just have to remember that the negative is the nonmetals, the positive is the metals. Now, it might be a good idea to write this in above the columns in your periodic table that we glued in your book. So you could write in like +1, +2, +3, skip, -3, -2, -1, skip. All right, so last thing, let's just do a couple of examples of predicting what type of ion an element will form. So let's predict magnesium, let's predict chlorine, and aluminum, and phosphorus, and hydrogen. Okay, that's a lot, but this is very easy. So magnesium, it's right here in the second column, the +2 column. So it's going to lose 2 electrons to become a +2. Chlorine is over here. It's a halogen. It's in this column. It's going to gain 1 electron to become a -7. Or it's going to gain, it has 7 valence electrons. It's going to gain 1 electron to become a -1. Sorry, I'm talking too fast here. -1. Aluminum is in this column. It's got 3 valence electrons. It can lose those 3 to become stable. So it can become a +3. Phosphorus, it's right here. It's in the -3 column. So it would become a -3. And hydrogen is in this first column. So it would become a +1. So hopefully you see how that works. Hopefully you understood what I was talking about with valence electrons. But if all else fails, just memorize these numbers. +1, +2, +3, skip, -3, -2, -1, skip. And know what an anion is, that they're formed by nonmetals, they're negative, and a cation. They're positive, formed by metals. Remember, electrons are negative, so losing electrons makes you positive, gaining electrons makes you negative.